Have you ever wondered how your virtual machines, just sitting there in the cloud, actually talk to the internet? Well, it's not magic. It's all thanks to a little something called an internet gateway. Today, we're going to pull back the curtain and see exactly how it works by looking at two totally different ways of doing things, the AWS way and the Google Cloud way. So here's our game plan. We'll kick things off with the absolute basics. What even is a gateway? Then we're going to dive into the AWS approach. Think of it like building a bridge. After that, we'll check out how Google Cloud handles it, which is more like following a path that's already there. We'll put them side by side and then wrap up with why these differences really, truly matter when you're building in the cloud. Okay, so first things first. What in the world is a gateway? The simplest way to think about it is like the front door to your house. It's the one single point that everything has to go through to get in or out. Without that door, your network is just, well, it's totally cut off from the outside world. Now, for the more official definition, a gateway is what lets data move between two separate networks. But here's the really important part. It often has to translate between them. It's kind of like a universal translator from Star Trek. It lets your private network, speaking its own private language, have a full conversation with the public internet, which speaks a totally different one. So it's not just a door, it's also the interpreter. You know, the perfect real-world example is sitting in your house right now, your Wi-Fi router. Every single one of your devices, your phone, your laptop, that smart TV, they're all on your private little home network. That router, that's the gateway. It's the one thing connecting all of them to this huge separate network we call the internet. It handles all that traffic and all that translation without you even thinking about it. So when we move this idea to the cloud, it looks something like this. Your virtual private cloud, or VPC, is like your own private island. It's totally isolated. To connect that island to the rest of the world, the internet, you need to build a bridge. And that bridge, well, that's your internet gateway. Okay, let's get into our first real-world example, starting with Amazon Web Services. AWS treats this gateway like a very real, very tangible object. It's an explicit bridge that you, the user, actually have to build. Right, so in the AWS world, an internet gateway, they call it an IGW, doesn't just appear out of nowhere. It's a separate component, a resource that you can see and manage right inside your VPC. You have to make a conscious choice to create it, and then you have to, well, virtually attach it to your network. And getting it working is this clear three-step process. First, you literally click a button to create the gateway resource. Second, you attach that gateway to your VPC. And third, and this is the part people sometimes forget, you have to update your network's roadmap, its route table. You add a rule that basically says, hey, for any traffic that's going anywhere outside our private network, that's what 0.0.0.0/0 means, send it across our brand new bridge, the Internet Gateway. Now, once you've set it up, the AWS IGW is an absolute beast. It's highly available, so you don't have to worry about it being a single point of failure. It handles traffic coming in and going out, and it does this super critical job called Network Address Translation, or NAT. Think of it like a receptionist. It takes the private, internal-only address of your virtual machine and gives it a public address so it can talk to the rest of the world. All right, let's completely switch gears. If AWS gives you a pile of bricks to build a bridge, Google Cloud Platform, well, it just points you to a path that's been there the whole time. Their whole approach is completely different. It's implicit, and it's all about software. You know, this quote from a Google Groups discussion just says it all perfectly. In GCP, you don't create an internet gateway. It's not a thing you can click on or manage. It's just a destination, a next hop that the system already knows how to get to. There's literally no command for create internet gateway. It doesn't exist. So the main thing to get about GCP is this. Internet access is all about routing. It's not about attaching some component. The gateway is just a logical idea, a target you point traffic towards. Your job isn't to build the bridge, it's just to draw a line on the map that leads to it. And the whole process is so much simpler because of this. When you create a network in GCP, it comes with a default route to the internet, already built in. The map is basically pre-drawn for you. So if you want a virtual machine to use that path, you just do two things. Give it a public IP address, and make sure your firewall isn't blocking the traffic. That's it. The path is just waiting there to be used. This command here really drives the point home. Look at what you're doing when you manually create a route. You're not pointing to some gateway object you built earlier. You're just telling the system that the next hop on the journey is the default internet gateway.
You are defining a path, not constructing a bridge.
Okay, so we've seen the two playbooks. AWS is all about building that explicit bridge, while GCP is about following an implicit path. Let's put them right next to each other so we can really see how different they are. This table really lays it all out. In AWS, the gateway is a thing. It's a real component you have to create and attach. In GCP, it's just a direction. It's a target for a route that's already there. And this fundamental difference changes everything, right down to how you automate things. In AWS, you might write a script that looks for someone creating a new gateway. In GCP, that's impossible. Instead, you have to watch for something totally different, like a virtual machine getting a public IP address. Okay, so we've dug into the technical weeds, but what's the so what? Why should you actually care if your cloud uses a bridge or a path? Well, it turns out this difference in architecture has some really big real-world consequences. So, what should you take away from all this? First, it's a difference in philosophy. AWS is explicit. It makes you do the work. GCP is implicit. It assumes you want internet access and makes it easy. This directly impacts how you handle security. In AWS, the gateway itself is a natural place to monitor. In GCP, your security focus shifts to watching who gets a public IP and what your firewall says. The methods are different, but remember, the end goal is exactly the same, giving you secure, scalable internet access. Let me give you a super concrete example. Let's say you're on a security team. In an AWS shop, your security playbook might have a rule to scan for orphaned internet gateways. Gateways that are just sitting there, not attached to anything, which is a big red flag for a mistake. In GCP, that check is completely useless. Instead, your playbook would have a high-priority alert that fires anytime a production machine suddenly gets an external IP address without approval. Same threat, totally different way of catching it. And this all leads to a final, bigger question. We're seeing this massive trend where networking is becoming less about virtual hardware and more about pure software logic. GCP's approach feels very much like the future. So the question I want to leave you with is this. As cloud networking keeps evolving, do you think the idea of an explicit gateway that you have to create will eventually just become a thing of the past? Will it all just be routing rules and policies? Definitely something to think about. Thanks for tuning in.